Alright, so we are looking at KC8 now. Yes, we are starting with target B. So we're skipping A for now. We're going to come back to it later. It's because B and C go together the best, so I want those to go on the quiz together. So we're going to start with target B. And our mastery learning objective for 8B.1 is I can simplify rational expressions by factoring the numerator and denominator to divide out the common factor. So, first vocabulary, what is a rational expression? A rational expression is a fraction in which the numerator, which is the part on top, right, and denominator, which is the part on bottom, are polynomials. Okay, so now instead of just like a number like 3/5, right, it might be x plus 3 over x plus 5, right? So you're going to have variables in your fraction. Then a simplified rational expression, which is really what we want to get to, is a rational expression where the numerator and the denominator have no common factors. So basically you divide any common factors or any common number away. So we're going to look at it with regular numbers first. Right. So our first one, we're going to simplify these expressions. So 15 over 21. Right. If you think about the fraction 15 over 21, we can simplify that. And you're thinking about what are the factors of 15 and what are the factors of 21. So 15 is really 3 times 5. And 21 is really 3 times 7. Okay. They have a common factor of 3. So it simplifies to 5/7, right? That we've all done before. So we're going to kind of connect it back to that idea once we have polynomials as well. Okay. So if we look at B, 5 over 5x, right, I'm just going to quickly write this as 5 over 5 times x, right? Anytime you have a coefficient on your variable, really you're multiplying the two of them. So again, I can cross out the 5s. Those are common factors. They divide away. And what are we left with? This is where we have to be careful in a situation like this. On top, if I divide away a 5, I'm not left with 0. I'm left with 1. Okay. So let's always keep at least a 1 in the numerator. The numerator never fully goes away. Okay, you're always going to have something in your numerator if you have a denominator. Okay. So that's probably the biggest mistake I see with 5 divided by 5x. They see everything divides away, and a lot of students will just put equals x instead of 1 over x. So be very careful with that numerator dividing away. All right, looking at these next problems, this is where our factoring practice is really going to come in handy. This whole unit has so much factoring in it. So we want to make sure we are factoring correctly. If you look at x squared plus 5x, right? This has a greatest, or a common factor of x. So I can take that x out, and I'm left with x plus 5 over. We have x squared on the bottom, and then I'm going to write that as x times x. Anytime you have something squared, it makes it easy to really see what factors you have the same. Now, if you look, there's an x here and an x here. So what are we left with? Right? On top, we have x plus 5. You can keep it in parentheses, but now that it's the only thing, it's not being multiplied by anything, you technically don't need them. X plus 5 over x. Okay. Now I'm going to make my second important point. Only cancel out multiplication. The biggest thing students want to do here is they see an x here and an x here, and they want to cancel that. That is incorrect, because this is being added and this is being divided. Be careful. Addition and division are not opposites. Right? So here, technically there's a multiplication sign. Multiplication. I can divide them away because division is the opposite of multiplication. Here, I'm adding and then dividing. Not opposites. Those don't cancel out. So this is our final answer. Right, again, that's probably one of the biggest mistakes that students make. Okay. Looking at our next one, if we look up here, x squared minus 5x minus 6, we have to factor that. If you're getting really good at your factors and don't need to draw this x anymore, that's fine. Right, remember, we're seeing what multiplies to -6 and adds to -5. So if you can already see those numbers, don't worry about doing this. But I'll still do the work over here for now to help us out. In later videos, I'm going to slowly stop doing that. And that's because we are supposed to have practiced a lot of factoring, so we should be getting pretty good at it. So what multiplies to -6 adds to -5? -6 and +1, right? -6 times 1 is -6. -6 plus 1 is -5. Okay? So this is the same as x minus 6, x plus 1. Then if you look at your denominator, x squared minus 1, this is difference of squares. Okay. So recognizing that difference of squares is important. So it goes 1. Right, again, we practiced that in our factoring review. Okay, so if this is a square and this is a square, I just square root both of them. Square root of x squared is x, square root of 1 is 1, and we change the signs between them. Okay, so be careful with those difference of squares problems. Now we want to see if we have any common factors. We have an x plus 1 and an x plus 1. Okay, since these are being multiplied, I take out the whole factor. Okay, the whole thing that's being multiplied. What do we have left? X minus 6. Again, a lot of students want to take out the x's here, but this x has a subtraction, then dividing, and subtraction. All right, there's no multiplication, so our division is not the opposite for anything going on. So this is our final answer. All right, looking at letter E, 3 times x plus 6. Right? Here we have a greatest common factor of 3. When we take that out, we get x plus 2. Okay. Opposite of distribution. Then we have x plus 2 on the bottom. Thinking about what cancels out, I have a whole x plus 2 here and a whole x plus 2 here. Technically, in your denominator, you also keep a 1. But anything divided divided by 1 is just itself. So it's not as important of a rule to really remember as when you lose everything in your numerator to put a 1 there, because the 1 in the denominator always divides away. So this will equals 3. All right, looking at F, same type of thing, right? This has a common factor of 3. We have to factor our numerator. We're multiplying to negative 15, adding to negative 2. So that's negative 5 and positive 3. What are our common factors? We have an x minus 5 here and an x minus 5 here. So we are left with 3 over x plus 3. And that is it. I'll see you guys tomorrow. Have a good rest of your day.